Let us study chemistry together with CBSE Chemistry Tips and Tricks.
Question number 2. Which of the following statement concerning the quantum numbers are correct? Angular number determines the three-dimensional shape of the orbital. Principal quantum number determines orientation and energy of the orbital. Okay. Magnetic quantum number determines the size of the orbital. And the last one, spin quantum number determines the orientation of the spin of the electron. So we have to check which statements are correct or which all statements are correct. Okay, we can check that. Let us break down what each quantum number denotes and then evaluate the given statement. Okay, so what principal quantum number represent? It represents the size and energy of the orbital. Okay, now second one is what? Angular momentum L, right? It represents the three-dimensional shape of the orbital. And magnetic quantum number represents the orientation of the orbital. And spin quantum number represents the orientation of the spin. Okay, right? Now check the question. Angular quantum number represents the three-dimensional shape of the orbital. Angular quantum number means azimuthal quantum number. Okay, so it is correct. Second one is what? The principal quantum number determines the orientation and energy of the orbital. Okay, so it is wrong, right? Orientation, no, that is wrong. We know principal quantum number represents what? Size and energy, not orientation, right? Now third one is what? Magnetic quantum number determines the size of the orbital. Wrong. It is determined by principal quantum number. Last one is what? Spin quantum number of the electron determines the orientation of the spin. Perfectly correct, right? So option 1 is correct. Option 4 is correct. Question is what? Which of the following statement? Which means more than one right answer is there. Okay, so 1 and 4. Okay, right? Hope all of you understand. Based upon the above information, arrange the following orbitals in the increasing order of energy. Okay, so for doing this question, you must know a hint. That is N plus L rule. Okay, see, this is the rule. Lower the N plus L value, lower will be the energy. Orbitals with a lower sum of N and L have lower energy. What is N value? N value means principal quantum number. For example, for 1s, 1 is the N value. Okay. Now, what is L value? L value means, remember this, for S, L value is 0. For P, L value is 1. For D, L value is 2. For F, L value is 3. Remember this, okay? Then only you can do this question. Now, if N plus L value is same, then, okay, before that, remember, lower the N plus L value, lower is the energy. Higher the N plus L value, higher will be the energy. Then, if they are same, if the sum is same, then another hint, lower the N value, lower will be the energy. Okay, when we do question, you will get a good idea. Okay, first question, okay, we have 1s, 2s, 3s, and 2p, right? For 1s, what is N value? 1, right? S value, what is L value? It is 0. N plus L, right? N plus L. N value is 1, L value is 0, so 1. 2s, what is that? 2 plus 0, okay, right? 3 plus 0, what is that? 3. Then 2 plus, for P, what is that? 1, right? Okay, so 2 plus 1, 3. Now what you have to check? If the N plus L value are same, the one which have lower N value will have lesser energy. Clear? So if you check, you can see 3s and 2p have same N plus L value, right? In that 2p has lower principal quantum number N value, right? So which one will be having the maximum energy? Of course, it should be 3s. Then it will be what? 2p. Correct, right? Then which one? 2s, right? And which one will be having least energy? It should be 1s because it have least n plus l value. Clear, right? So we can write it in order, increasing order. 1s has least energy, then 2s, then 2p, and the maximum energy is for 3s. And that is our right answer. Hope you understand. Very important. Okay. See, for second question, it is 4s, 3s, 3p, and 4d. Okay, we can write the n plus l values. Okay, n plus l values. So for 4s, what is n plus l value? N value is 4. For s, l value is 0, so it is 4. Second one, n value is 3. For s, l value is what? 0, so it is 3. Now third one is what? 3p, right? 3p. N value is 3. L value is 1, so 4. Now for 4d, n value is 4. L value for d, what is that? 2. 4 plus 2, what is that? 6. Okay, right? So it is very clear that which one have maximum energy? It is for 4d, right? And which one has least energy? Fourth position, which one? It should be 3s. Now for second and third position, we have two persons. One is 4s and one is 3p. Now if n plus l values are same, then the one which have lower n value will have least energy, right? So between 4s and 3p, who have lesser energy, of course 3p. So that will be on the third position and this will be on the second position. Correct, right? So see, least energy for which one? 3s, right? 3s. Then comes 3p. Then second position for 4s. First position for 4d. Hope all of you understand. Easy, right? Very, very easy. See, for third question, 5p. Okay, so for 5p, what is n plus l value? 6, right? Now 4d, 4 plus 2, 6. 5d, 5 plus 2, 7. 4f, 4 plus 3, 7. 6s, 6 plus 0, 6. So you remember the l values, right? For s it is 0. For p it is 1. For d it is 2. And for f it is 3. Okay, so you are getting the l values from here and n value is the principal quantum number, first numbers, these numbers. Okay, so we are adding it and we are getting these numbers. Okay, now check which one has maximum. See, you can see these two, right? These two have what? These two have same n plus l value. These three have same n plus l value, right? Now out of 5p, 4d and 6s, all of them have same n plus l value. So which will be the one having least energy? Of course, the one which have least n value. Here 5p, 4d and 6s, right? Which one have least n value? Of course 4d. N is equal to 4, right? Okay, so that will be having least energy. Then which one? Then it will be 5p. N value is 5. Then which one? 6s. What is n value? 6. So first one, n value is 4, then 5, then 6. Okay, right. Now you have 5d and 4f. Both of them have same n plus l value. Now which one will be having least energy? So for that purpose, you have to check n value. 5d n value is 5 and 4f n value is 4. So of course, the one which have lesser n value will have lesser energy. Clear? So this will be the order. For the last question, I already write the n plus l values. You can check it, okay? 5f, 5 plus, for f it is what? 3, right? L value is 3. So 5 plus 3, 8. For 6d, 6 plus 2, 8. For 7s, 7 plus 0, 7. For 7p, 7 plus 1, 8. Okay, right? Now you already know a good idea, right? about n plus L values. Now see, if you check first one, second one and fourth one, the n plus L value is 8 and for the third one it is 7. So which one has least energy? Of course 7s, right? Now out of first, second and 4 having n plus L value same, how to understand which one has least energy? Of course the one having least number of n. So what is that? 5f. Then which one? 6d. Then which one? 7p. Got it right? Okay, so that is all about n plus L rule. See, next question is wavelength of different radiations are given below. See, lambda A is 300 nanometer. For B it is 300 micrometer. For C it is 3 nanometer. And last one it is 30 angstrom. Okay, so I am writing all this thing in SI unit. So 300 into 10 raised to minus 9 meter. 300 into 10 raised to minus 6 meter. Now 3 into 10 raised to minus 9 meter. And 30 into 10 raised to minus 10 meter. Okay, right? Now what is our task? Arrange these radiations in the increasing order of their energy. Very easy, right? Regarding radiations, if they ask energy, you have to use which equation? Equation is equal to, equation for energy is equal to what? H nu. And what is nu in terms of wavelength? It is hc by lambda. So from the equation it is clear that E is inversely proportional to lambda, which means what? If lambda is high, energy is less. Clear, right? That is inverse relation. Correct. We have to write it in the increasing order, right? So you have to write the least one as the first one. So which one has least energy? See, the one which has maximum lambda will have least energy. Check it. Which one? See, to avoid confusion, see, I am making the powers of all these numbers as 10 raised to minus 9. And for A, it is already 10 raised to minus 9. For C also, it is already 10 raised to minus 9. So no need to do anything. Okay. Now, for B, okay, you check for B, it is 300 into 10 raised to minus 6. So how to make it 10 raised to minus 9? So multiply with 10 raised to minus 3. Divide with 10 raised to minus 3. Correct, right? Okay, now it become what? 300 into 10 raised to minus 6 into 10 raised to minus 9 is what? Sorry, 10 raised to minus 6 into 10 raised to minus 3 is what? 10 raised to minus 9. By 10 raised to minus 3. Correct, right? Now on calculating, what you will get? 300 into 10 raised to 3 into 10 raised to minus 9. Correct, right? So what you will get? You will get like 300 into 1000, right? So it become like this, right? Into 10 raised to minus 9. Correct, right? 3 and 5 zeros. Okay. Now this one, D. How to convert in terms of 10 raised to minus 9? 30 into 10 raised to minus 10. You have to make it 10 raised to minus 9. So multiply with 10 and divide with 10. Okay, right? Now what you will get? Zeros get cancelled, right? So it become 3 into 10 raised to minus 9. Clear? Hope all of you understand. So these are our values, okay? In terms of 10 raised to minus 9. For A, for C, for B this one, okay? And for D this one. Clear, right? Now I am rewriting this, okay? I am rewriting this. Now check which one has maximum wavelength. It is for B, right? Correct. Okay, so it will be having least energy as per our relation. Correct. So B have least energy, right? Then which one? A, right? A have 300 here. So A. Then if you check C and D, they have same wavelength. So of course, same energy, right? C and D have same energy, same wavelength, same energy. Okay, right? Remember, wavelength and energy is inversely connected. If the wavelength is more, energy will be less. But if the question is about frequency, not like that, okay? what is equation? E is equal to h nu. So if frequency increases, energy also increases. Remember it. Assertion: black body is an ideal body that emit and absorb radiation of all frequency. First of all, you have to by heart the definition of black body. That is very important. A black body is defined as a physical body that absorb all incident electromagnetic radiation regardless of frequency or angle of incidence. Okay. Because it absorbs all incident radiation, so it is also the best possible emitter of thermal radiation. So it can emit and absorb radiation of all frequencies, right? Correct. By definition, they are bodies which can emit and absorb radiation of all frequencies. So of course, the assertion is perfectly correct. What is the reason? The frequency of radiation emitted by a body goes from a lower frequency to higher frequency with an increase in temperature. If you increase the temperature, the frequency of the emitted radiation is also increasing. That is the reason. Okay. Anyhow, it does not explain the assertion. Okay. So, anyhow, answer is not A. Now, we are going to check whether that reason is correct or false. Okay. Now, see, according to Wien displacement law, which you will learn in physics, see the relation is like this. Lambda maximum maximum wavelength of the emitted radiation is inversely proportional to temperature, which is inversely proportional to temperature. And you already know, right? Lambda is what? C by nu, right? Lambda and frequency are also inversely related. Lambda and temperature is inversely related. So what you can write? Frequency maximum will be directly proportional to temperature. Lambda and temperature is inversely related. Lambda and frequency are inversely related. So we can directly say what? Frequency and temperature are directly related, not inversely. Okay. So higher frequency means higher temperature. Perfect. But it does not explain assertion. It does not explain why why a black body can emit or absorb radiation. Nickel atom can lose 2 electrons to form Ni2 plus ion. The atomic number of nickel is 28. From which orbital will nickel lose 2 electrons? Very, very easy question, right? Okay, we can check it out. First, we can write the electronic configuration of nickel, not Ni2 plus nickel, okay? Ni. So we know 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d8. Okay. Always remember 4s2 is 20, then 8. So 3d8. Okay. Now 2 electrons is losing, right? Then it will become Ni2 plus. So remember, electrons will be lost from the highest principal quantum number. Okay, always remember it. Okay, then only electron will be lost from 3D. Okay, so here 2 electrons are losing. So 2p6, 3s2, 3p6. Then 2 electrons will be lost from 4s orbital. So what is the question? From which orbital will nickel lose 2 electrons? From where? It is from 4s orbital. Clear, right? Okay. In which of the following pairs the ions are isoelectronic? Direct question, right? What is isoelectronic? The one which have same number of electrons, right? Now we can check the first question. See, Na. How many electrons are there? 11. Na plus means what? 10, right? 10. Now magnesium, how many electrons are there? 12. Atomic number is 12. Now M2 plus means what? Losing 2 electron. It become 10. So they are isoelectronic. Second question, Al3 plus. See, Al, how many electrons? Al means 13 atomic number. Now 3 electrons lost. So 10. Oxygen, what is atomic number? 8, right? Adding of 1 electron, 9. So they are not isoelectronic. First pair is isoelectronic. Third one is what? Sodium is 11, losing one electron, 10, right? Oxygen 8, gaining 2 electron. 2 minus means gaining 2 electron, become 10. They are isoelectronic. Now fourth one, nitrogen. Nitrogen is 7, adding 3 electron, 10. Chlorine. Chlorine is what? 17, adding 1 electron, 18. Number of electrons are not same. So first one and third one are isoelectronic. Second and fourth are not. Clear, right? Direct. If you know what is isoelectronic species, you can do this. What is the wavelength of light emitted when the electrons in a hydrogen atom undergo transition from an energy level n is equal to 4 to an energy level with n is equal to 2? See here, what is the scenario? Electron is shifting from one shell to another shell, right? From n is equal to 4 to n is equal to 2. Correct, right? Definitely at that time energy will be released out in the form of light, and we are supposed to find the wavelength of that light. In such scenarios, what we have to use? Which equation we have to use? Of course, it is Rydberg formula, right? What is that? 1 by lambda is equal to RH, Rydberg constant, into 1 by n1 square minus 1 by n2 square. Correct, right? And here what is n1 and n2? Remember, n1 is n final. In this particular equation, n1 is n final. So what is that? 2. Remember it, okay? That is very important. n2 is n initial, and what is that? 4. And what is Rydberg formula? Rydberg value. It is 1.097 into 10 raised to 7. Okay, right? That is in meter. Okay, that is in meter. So if you are using RH as 1.097 into 10 raised to 7 meter inverse, your lambda will be in meter. Or if you are using this value, centimeter inverse, you will be getting lambda in centimeter. That's it, okay? You can use any of that. Now here anyhow I am using SI unit. Okay, let us see. Substitute, okay? RH is what? 1.097 into 10 raised to 7 by 1 by 2 square minus 1 by 4 square. On calculating, you will be getting like 1.97 into 10 raised to 7 into 3 by 16. On calculating, you will be getting like 2.06 into 10 raised to 6 meter inverse. Okay, then lambda taking a reciprocal of that, which means 1 by 2.06 into 10 raised to 6. You are almost getting like 4.86 into 10 raised to minus 7 meter. Now if you want to represent this in nanometer, do like this: 486 into 10 raised to minus 9 meter. So it becomes what? What is the maximum number of emission lines when the excited electron of a hydrogen atom in n is equal to 6 drops to the ground state? Okay, so here we have to find the maximum number of emission lines. What is given? N value is given, right? Definitely electron on a higher shell will come back to the lower stationary shells, right? On doing so, what they will do? They will emit radiation. How many such emissions are possible if electron is now on the 6th shell or on the nth shell? Okay, I will give you a simple trick. This is the equation: maximum number of emission lines possible if n value is given. So if n value is given, take n minus 1 value. So n is equal to 6. What is n minus 1 value? 5. Then take the next smaller number. Like that, you add up to 1. So what is that? 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 emissions are possible. Understand? Now, if the question was how many emissions are possible when the excited electron of a hydrogen atom is n is equal to 5, then what do you have to do? Start from 4. 4 plus 3 plus 2 plus 1. Understand, right? Here it is starting from 6. So our calculation has to start from 5, n minus 1. If n is equal to 6, start from n minus 1, that is 5. Calculate the wave number for the longest wavelength transition in the Balmer series of atomic structure. Okay, see here electron is shifting from a higher shell to second shell. From where we understand it is second shell. Balmer series, right? Balmer series means what? Electron is coming back to second shell. So which equation for wave number? Wave number is equal to 1 by lambda, that is equal to RH into 1 by n1 square minus 1 by n2 square, right? Now what is n1 and n2? n1 means n final, right? Not n initial. For Balmer series, what is n final? It is 2. Balmer series, right? Now what is n initial? N initial means n2. Okay, what is that? Okay, n2 means n initial. What is that? See, question says that we are getting longest wavelength. Longest wavelength means n2 is equal to n1 plus 1. So here it will be what? 2 plus 1. So it should be 3. Correct. Generally we can say for longest wavelength n2 is equal to n1 plus 1. Here it is 3. Now what if the question is about shortest wavelength? Then you have to take n2 as infinity. Infinity. Remember it, okay? Very important hint. If the question is about shortest wavelength, you have to take n2 as infinity. Okay? n2 as infinity. If it is about longest wavelength, n2 is equal to n1 plus 1. And here what is n1? 2. 2 plus 1, 3. Direct substitution, you will be getting the answer. Okay, we can substitute. Now what is the value of RH? RH is equal to 1.09677 into 10 raised to 7 into 1 by 2 square minus 1 by 3 square. Okay, see, on calculating you will get 1.09677 into 10 raised to 7 into 5 by 36. On calculating you will get 1.523 into 10 raised to 6. As we use this value, okay, this value, your answer will be in meter. Okay, 1.523 into 10 raised to 6 meter. Okay. Sorry, it is wave number, right? So meter raised to minus 1. Meter raised to minus 1. Sorry, not meter. Meter raised to minus 1. Wavelength is in meter, okay? See, nu bar will be in meter raised to minus 1. Calculate the number of unpaired electron in the following. First one is copper. You have to write the configuration. Copper atomic number is 29. You must by heart all the configurations, okay? 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1. Exceptional configuration, right? Copper. 3t10. Correct. Now check. 3d is fulfilled, okay? You know 3d is 5 orbitals. 1, 2, 3, 4, 5. And total how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No unpaired electron. Now check 4s. 4s have only 1 electron. Correct, right? Which means number of unpaired electron is what? 1. Clear, right? Number of unpaired electron is 1. Remember, all these are paired, right? All these are paired. No unpaired electron in the inner shells. You have to check only 4s and 3d. Now 3d is fully filled. 4s have 1 unpaired electron. Clear, right? So answer is 1 unpaired electron. Clear? Now what is the next question? Next question is Cu2 plus. Okay, now check. See, 1s2, 2s2, 2p6, 3s2, 3p6. Copper 2 plus means what? 2 electrons are lost by copper, which means first electron will be from 4s and second electron will be from 3d. So 3d become 3d9, 4s become 4s0. Total 2 electrons are missing. Okay, now check how many unpaired electrons are there. Okay, For D, how many boxes? How many orbitals? 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now check how many unpaired electron? 1. Again, right? 1 unpaired electron. Okay, right. Now next one is what? Manganese. Mn. For manganese, again write the configuration. Atomic number is 25. So what is that? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. What is 4s2? 4s2 is 20. Then 25, right? 3d5. Now check 3d. 4s is fully filled, right? So just check 3d. 1, 2, 3, 4, 5 boxes. How many electrons? 5. So 1, 2, 3, 4, 5. How many unpaired electron? 5 unpaired electron. Got it right? Clear? Easy. See, next one is what? Chromium. Chromium, right? Chromium. What is the configuration? See, 1s2, 2s2. You remember the atomic number, right? 24. 2p6, 3s2, then 3p6. Special configuration, so 4s1 and 3d5. Now it's very clear 4s is half filled and 3d is also half filled. Right, 1, 2, 3, 4, 5. What is the number of unpaired electron? Number of unpaired electron is equal to 1 plus 5, it is 6. Now what is the last one? O2 minus, right? Okay, first we can write oxygen. Oxygen we can write, oxygen. So oxygen, you know, 1s2, 2s2, 2p4. Atomic number is 8, right? Now O2 minus, what is that? 1s2, 2s2, 2 extra electron will be added in 2p. So it becomes 2p6. Okay, now check 2p. 2p means how many orbitals? How many boxes? 3 boxes. How many electrons? 6. 1, 2, 3, 4, 5, 6. How many unpaired electron? 0. 0 unpaired electron. Okay, 0 unpaired electron. Clear? Okay, this is how you have to find number of unpaired electron. Clear, right? Easy. Calculate the wavelength of an electron moving with a velocity of 2.05 into 10 raised to 7 meter per second. See, for this type of questions, in the question you can see a particle, electron, okay, moving with some velocity. Then, to find wavelength, you must use de Broglie wavelength. Okay, don't try to use lambda is equal to C by nu. This is for photons, okay? This is for photon. Don't use this equation for electrons or any other particle having mass. Remember it. If the question is like car, or his question is like about some small object moving with some velocity or moving with some momentum, remember that is very, very important. You have to use this particular equation. Otherwise, your answer will be wrong. Now check direct substitution. Lambda is equal to H value, you know, 6.6 into 10 raised to minus 34 by. What is the mass of electron? That you have to by heart, okay? 9.1 into 10 raised to minus 31 into velocity is given, right? 2.05 into 10 raised to 7. On calculating, you will get 3.55 into 10 raised to minus 11 meter. And remember, instead of electrons, sometimes they will be giving like an object of mass of 10 gram. You must convert gram to kilogram, otherwise your answer will be wrong. 10 gram, how to convert to kilogram? 10 into 10 raised to minus 3. Okay, here it is electron and you know the mass of electron in kilogram, that is 9.1 into 10 raised to minus 31. Okay, hope all of you understand. Write the electronic configuration of the following ions. See, first one is H minus. See, first you write H, okay. H is what? 1s1. Correct, right? Atomic number is 1. That you must know, okay. Now, H minus means what? We are getting an extra electron. It become what? 1s2. So, first one is okay, right? Now, second one. Sodium. See, sodium, you know, atomic number is 11. What is the configuration? 1s2, 2s2, 2p6, 3s1. Now, Na plus means losing one electron. It become what? 1s2, 2s2, 2p6. Electron will be lost from the outer shell, right? Okay. Now what is the next one? O2 minus, O2 minus. Okay. O2 minus. See, for that oxygen is what? 1s2, 2s2, 2p4. What is the atomic number of oxygen? 8, right? So what is O2 minus? 2 electron adding extra. 1s2, 2s2, 2p6. Correct? Now what is the last one? Fluorine, right? Fluorine minus. Fluorine atomic number 9. What is the configuration? 1s2, 2s2, 2p5. Correct? Now fluorine minus means 1 electron extra. So what is that? 1s2, 2s2, 2p6. Correct, right? Easy. Okay. Now moving to the second question. Second question is, what are the atomic numbers of elements whose outermost electrons are represented by? So 3s1, right? So it's like 1s2, 2s2, 2p6, 3s1. Now count this 2 plus 2 plus 6 plus 1. So what is that? 11. Atomic number is 11. And if they ask what is the atom or element, it's sodium. Now next one is what? 1s2, 2s2, 2p3. Okay. So add this 2 plus 2 plus 3. 4 plus 3 is 7. It's nitrogen. Now what is the next one? 1s2, 2s2, 2p6, 3s2, 3p5. Add all those things. 2 plus 2 plus 6, 10. 10 plus 2, 12. 12 plus 5, 17. And what is 17? Atomic number 17 is chlorine. Right. They ask atomic number. No need to write the name of the element here. But if they ask, you have to. Which elements are indicated by the following configuration? That is the third question. Second question, all of you understand, right? Easy. Which atoms are indicated by? Okay. See, helium. Helium is what? 1s2. Then 2s1. So what is atomic number? Atomic number is 3, right? 2 plus 1, 3. And 3 is lithium. Neon. Neon, what is the configuration? 1s2, 2s2, 2p6. Then what is left here? 3s2, 3p3. Correct, right? What is atomic number? 2 plus 2, 4. 4 plus 6, 10. 12, 15. 15, what is that? Phosphorus. Now comes argon. Argon, what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6. So it is 18, right? On adding this, you will get 18. Okay. Now what is left? 4s2, then 3d1. So total 21, right? 21. On adding all this, you will get 21. And what is the element? Scantium. Scantium, right? Okay. So easy, right? All questions are easy. The bromine atom possesses 35 electrons. It contains 6 electrons in 2p orbital, 6 electron in 3p orbital, and 5 electron in 4p orbital. Which of these electrons experience the lowest effective nuclear charge? Remember this hint. If the subshells or if the orbitals are closer to the nucleus, then it experiences more effective nuclear charge. If it is farther, definitely the effective nuclear charge or attraction experienced by the orbital will be less. That's it. Now here you have 2p, electrons in the 2p orbitals, electrons in the 3p orbitals, and electrons in the 4p orbitals. Right. So here subshells are same, right? The orbitals are same. Now just check the principal quantum number. Okay, otherwise you have to check off-bow principle. Okay, you have to check the order. Here it is easy. All subshells are same. Correct, right? Then just check the principal quantum number. Which one is least? 2p. 2 is least, right? So 2p experience maximum effective nuclear charge, then 3p, then 4p. See, 4p is maximum far away from the nucleus comparing to 2p and 3p. So 4p experience least, lowest effective nuclear charge, and 2p experience maximum. Okay. Remember, you cannot use this rule everywhere. For example, 4s and 3d, which one experience more effective nuclear charge? Of course 4s. According to Aufbau principle, who is coming first? 4s, right? Then only 3d is coming, which means 4s is more closer to nucleus, and also the spherical shape, due to the spherical shape of s orbit, s have a huge tendency to penetrate towards the nucleus. So s 4s is experiencing more effective nuclear charge than 3d. That you keep in mind, okay? So such cases you have to use Aufbau principle. Among the following pair of orbitals, which orbital will experience the larger effective nuclear charge? See, it's very easy. See, for the first question you have 2s and 3s, okay? So here the subshells are same, correct, right? The orbitals are s orbitals we have, correct, right? In such cases, what you have to check? You have to check principal quantum number. If the principal quantum number is higher, for example, here principal quantum number is 2, here it is 3. The one which have higher principal quantum number experience lesser effective nuclear charge. So which will be having more effective nuclear charge? 2s. It's easy, right? 2s is coming first. On filling first 1s, then 2s, then only 3s is coming, right? Which means 2s is more closer to nucleus than 3s. Understand what I'm saying? If the orbitals are closer to nucleus, then they experience more effective nuclear charge. Clear? Okay, that's about first one. Next is 4d and 4f. If n values are same, if n is same, then this is the order, okay? S, P, D, F. S experience maximum, then P, then D, least for F. Now in this particular question you can see that, see, n value is same, so you have to check the subshell. So yeah, subshell number or subshells. Here D subshell and here F subshell. Which experience more effective nuclear charge? D. Easy, right? Okay, so it's 4D. Clear? Easy. Now next one is what? 3D and 3P. Same rule, okay, same. Again here you can see n value is same, right? Now check the subshell. D or P, which experience more effective nuclear charge? P, right? So 3P experience more effective nuclear charge than 3D. Clear, right? Easy. That's it. If the velocity of the electron in Bohr's first orbit is 2.19 into 10 raised to 6 meter per second, calculate the de Broglie wavelength associated with it. Direct, okay? Lambda is equal to h by mv or h by p. See, listen here, to confuse you, they give Bohr first orbit. See, Bohr first orbit, second orbit, whatever, they have given the velocity. And you know the mass of electron, right? Lambda you can find. For that purpose, this is not required. Clear? That is to confuse you. You will go and use some equation which contain what? N. Okay? So no need. Direct. Lambda is equal to h is what? 6.6 into 10 raised to minus 34. Now mass of electron is what? 9.1 into 10 raised to minus 31 into, see here they have given the velocity 2.19 into 10 raised to 6. See, if you don't know proper multiplication like power addition, power subtraction, you study that separately, okay? Otherwise very difficult to solve these things. Now I am going to write the answer directly. I am not going to teach you multiplication and division. 3.32 into 10 raised to minus 10 meter. Okay, that's it. The velocity associated with a proton moving in a potential difference of 1000 volt is 4.37 into 10 raised to 5 meter per second. If the hockey ball of mass 0.1 kg is moving with the velocity, calculate the wavelength associated with the velocity. See here an object is given, hockey ball, mass is given, they ask wavelength. Remember, wavelength associated with a particle, always go for what? Lambda is equal to h by mv. Don't use any other equation, okay? If the question is about wavelength associated with a particle, if the question is about wavelength associated with a radiation, you can use which equation? lambda is equal to C by nu. That you can use, okay? That is different scenario, photons. This is about a particle. Then direct. Apply the value 6.6 into 10 raised to minus 34 by, what is the mass here? 0.1 kg. Remember, if it is in gram, convert to kilogram. Here it is in kilogram, so no problem. Into, what is the velocity? Velocity is given 4.37 into 10 raised to 5. Don't use this 1000 volt. That is only to confuse you, okay? That is not needed here. Not needed here. So 6.6 into 10 raised to minus 34 by 0.1 into 4.37 into 10 raised to 5. So on calculating, you will get 1.5 into 10 raised to minus 28 meter. Clear, right? An element with mass number 81 contains 31.7% more neutrons as compared to protons. Assign the atomic number. Okay, let us assume number of protons be x. So what is number of neutrons? Number of neutrons will be x plus the element with the mass number 81 contains 31.7% more neutrons as compared to proton. Okay, so it is x plus 31.7 by 100x. Most common mistake is students write like neutrons is equal to 31.7 by 100x. This is wrong. Okay, more neutrons are there, right? Not simply 31.7% of proton. It is more. More is there, right? So x plus 31.7 by 100x. Like that you have to write. Okay, now you know mass number is what? Mass number is equal to number of protons plus number of neutrons. Correct? Okay, now see, we can solve this part first. 100x plus 31.7 x by 100. So what you will get? You will get 131.7x by 100. So what you will get? 1.317x. Clear, right? Clear. Now as per the question, what is the mass number? It is 81. 81 is equal to proton number is x, neutron number is 1.317x. So what is 81? Add it. 1x plus 1.317x, 2.317x. Clear? Now what is x? X is equal to 81 divided by 2.317. On calculating, you will get 34.95 approximately. Take the whole number because we are dealing with atomic number, right? Okay, 35. So what is the number of proton? What is the number of proton? Okay, so proton number is what? X, right? X. So 35. Okay, now see, by using this relation you can find neutrons, right? 81 is equal to proton number plus neutron number. So what is neutron number? 81 minus 35, you will get 46. Okay, now what we have to do? Assign the atomic symbol. For that purpose, you must know what is the element with atomic number 35. Bromine, right? Bromine. See, atomic number here, mass number here. And that is our answer. Got it right? Okay. It's pure mathematical, actually, no chemistry. An ion with mass number 37 possesses 1 unit of negative charge. If the ion contains 11.1% more neutrons than the electrons, find the symbol of the ion. Okay, here in this question they compare neutrons and electrons, right? Okay, so let us take the number of electron as x. Then can you say what should be the number of proton? Of course it is x minus 1. Why? Because see, it is very clear. It possesses 1 unit of negative charge, which means the number of electron is 1 greater than number of proton. So if number of electron is x, number of proton will be x minus 1. Right. Okay, right. Now, what about the neutron? See, as per the question, number of, if the ions contain 11.1 percentage more neutrons than electron. So number of neutron is what? X plus 11.1 percentage of X. Don't write neutron is equal to 11.1 by 100x. No. Plus X, okay. Common mistake. It's common mistake. You have to add plus X, okay. Keep that point in your mind. Okay, it's a common mistake. Now. What is mass number? Mass number is number of proton plus neutron. Proton is x minus 1. Neutron is x plus 11.1 by 100x. So you will be getting like x plus x 2x minus 1 plus 11.1 x by 100. On calculating you will be getting like 2x minus 1 plus 0.111x. Correct, right? Okay. So on calculating you will get what? 2x plus 0.111x is what? 2.111x minus 1 is equal to, what is the mass number? It's given in the question, right? 37. 37, right? 37. Okay. So take minus 1 to the side. You will get what? 38 is equal to 2.111x. Clear? Okay. Now divide 38 by 2.111. You will be getting like 18. Okay. So electron number is what? 18. Proton number is what? 18 minus 1. What is that? 17. And neutron number is what? See, use this equation. Okay. So what is that? Mass number is 81 minus proton number is what? Proton number is 17. Okay. Sorry. Neutron number is what? Mass number is 37. Mass number is 37. Not 81. Sorry. Minus proton number is what? 17. On subtracting, you will get what? 18. So neutron is 18, proton is 17, and electron is 18. And you know which element it is, right? It is chlorine, because proton number is what? 17. Mass number is what? 37. And it carry a negative charge. Clear? As per the question, it carry a negative charge. Clear, right? The energy associated with the first orbit in the hydrogen atom is minus 2.18 into 10 raised to minus 18 joule per atom. What is the energy associated with the fifth orbit? Straight question. See, for doing this question, you must know the equation for the energy of electron in the nth shell. So it is minus 2.18 into 10 raised to minus 18 by n square. Right. Sometimes they ask what this minus represent. Minus represent the electrons are bounded or attracted towards the nucleus. Okay, that is that minus represent. Okay, now just substitute it. Minus 2.18 into 10 raised to minus 18 by 5 square. On calculating you will get minus 8.72 into 10 raised to minus 20 joule. Direct substitution. Now sometimes they will ask like this, okay, find the energy associated with the first excited state. First excited state means second shell. Second excited state means third shell. Third excited state means fourth shell. That you keep in mind. Instead of asking directly, they can ask like that. Okay. See, next question is what? Calculate the radius of Bohr fifth orbit for hydrogen atom. Again, direct equation. Radius of the nth orbit. What is equation? Equation is A0, or you can say R0 n square. Now, what is A0 value? A0 value is 0.529 Armstrong or 52.9 picometer. Both are same. Okay. See, A0 in some school they teach like 52.9 picometer. Anyhow, both are same. Okay. N square. What is that? 5 square. So what is that? 0.529 into 10 raised to minus 10 into 25. See, if you are using picometer, it is 52.9 into 10 raised to minus 12. Both are exactly same. Okay. On calculating, you will be getting like 13.22 into 10 raised to minus 10. So in Armstrong, it is what? In Armstrong, it is 13.22 Armstrong, because 10 raised to minus 10 meter is what? Armstrong. Okay, right? Hope it is clear. Calculate the radius and energy of second Bohr orbit of Li2 plus. Okay, see, first of all, you must know that Li2 plus is a hydrogen-like species. What is hydrogen-like species? The species contain 1 electron, right? Total lithium have 3 electrons and Li2 plus have 1 electron. Okay, now there is an equation, right? For hydrogen-like species, what is the equation for radius? Equation is Rn is equal to A0 n square by Z, or R0 n square by Z. What is the value? In Armstrong, it is 0.529 Armstrong, or in picometer, you can use 52.9 picometer. Use any of that, use the unit appropriately. Okay, so if you are using Armstrong, 0.529 into n square, second, right? 2 square by, what is Z? Z means atomic number of lithium. Lithium is 3. Correct, right? Clear? Now, Armstrong means what? Into 10 raised to minus 10. Clear, right? On calculating, you will be getting like 0.7053 into 10 raised to minus 10 meter. Okay. Now, how to find energy? We have the equation with us, right? For hydrogen-like species, what is the equation for energy of electron in nth shell? It is minus 2.18 into 10 raised to minus 18 Z square by n square. Right. Now, what is equation? Minus 2.18 into 10 raised to minus 18. We are dealing with lithium. So, atomic number 3 square by n square. We are dealing with second orbit. So, 2 raised to 2 is 4. Clear, right? On calculating, we will get minus 4.905 into 10 raised to minus 18. Sometimes they will ask what this minus signify. This minus signify the attractive force between nucleus and electron. Electron is attracted towards the nucleus. Electrons are bounded by the nucleus. Okay, not inside the nucleus. Okay, outside, but it is bounded. Okay, by an attractive force. A 25 watt bulb emit monochromatic yellow light of wavelength 0.57 micrometer. Calculate the rate of emission of quanta per second. See, first of all, what we have to find? Rate of emission of quanta means rate of emission of photon. Okay, which means we have to find number of photons per second. Okay, that is what you have to find. It is a direct question. You can actually use this equation. Total energy of photon. Here it is very clear that more than one photons are coming. That is why they ask rate of emission, right? So total energy of photon is what? NH nu. If more than one photon is there, which equation we will use? E is equal to NH nu. Right. So if I divide with the time on both sides, what you will get? See, this is total energy. Okay. So if I am dividing time on both sides, you will be getting like this. Correct, right? Okay. Now, energy by time is what? Power. Correct, right? Now, N by T is what? This is what we have to find. Correct? Number of photons per time. Then H nu. Correct? So, what is that? N by T is equal to P by H nu. What is N by T? That is a rate of emission. Right. Rate of emission means what? N by T. So, I am writing rate of emission instead of that. Now, what is power as per the question 25 straight, right? By now h is always what, 6.6 into, or you can write 6.624, 6.634, you can write like that, 10 raised to minus 34 into, see they have given frequency, no, right, they have given wavelength. Oh, okay, for time being I am writing nu there. Okay, next step we can substitute. So what is that? 25, listen carefully, 25 by 6.6 into 10 raised to minus 34. Now you know what is frequency. Frequency is what? C by lambda, right? C by lambda. Instead of frequency, I am going to write that. C by lambda. Okay, C by lambda. Clear? See, it is actually C by lambda here. It will come up, right? It will come up. Denominator of the denominator become numerator. So C by lambda, lambda is going up. Okay, now substitute 25 into, lambda is what? Lambda is given in the question. It is 0.57 micrometer. Micro means what? 10 raised to minus 6 by 6.6 into 10 raised to minus 34 into C, 3 into 10 raised to 8. Now on calculating, you will be getting a rate of emission as 7.18 into 10 raised to 19. Okay, so that's it. Check it. Okay, it's a good question. You can expect this question. Rate of emission or number of photons per second. You can use this method. Expect this question for your exam. Okay. Which quantum number is not derived from Schrödinger wave equation? Which one? Of course, it is spin quantum number. Okay. It actually arises from experimental observations and was introduced to explain the structures in atomic spectra like Zeeman effect and Pauli exclusion principle. Okay. What is the next question? What are the four quantum numbers of 19th electron of copper? Okay, so we can write that. Copper 1s2, 2s2, 2p6, 3s2, 3p6. Now it become 18. So 19th electron is here, 4s1, right? Then you know copper 3d10. Correct. So this is the 19th electron. So what is n value? N value is principal quantum number which you will get from the shell number 4. Correct. Now what is azimuthal quantum number? That you will get from here, right? S. What is for S? What is L value? You know it, 0. Correct. For S it is 0. For P it is 1. For D it is 2. For F it is 3, which you already know. Now for L is equal to 0, which are the M values? You know M values ranges from minus L to plus L, right? So what is L here? 0. So minus 0 to plus 0. Okay, right? Okay, 0. Now S can be plus half or minus half. We can say plus half. Okay, right? Understood? What is the physical significance of the wave function psi and its square, psi square in quantum mechanics? For a hydrogen atom, explain what psi square represents at a given point in space. Basically, this psi is the solution of Schrödinger wave equation. And we are learning more about psi in higher classes actually. Schrödinger's time-independent wave equation describes how the quantum state of a particle behave in a potential field. That is slightly beyond your syllabus. Now we can check our particular question. What is the physical significance of the wave function psi and its square psi square in quantum mechanics? That is the question, right? See, check. You can see wave function psi does not have any physical significance. Remember it, okay? Remember. Now, what is psi square? It has physical significance. What is that? Gives the probability of finding an electron at a particular point in space. Clear? It gives you the idea. It gives you the probability of finding an electron in a particular point in space. Clear, right? So it is physically meaningful. Regarding hydrogen, what psi square represent? Same. It gives the probability of finding an electron at a particular point in space around hydrogen nucleus. Clear, right? Why are half-filled and fully filled electronic configuration considered more stable than other configuration? Explain in simple terms. See, same question they can ask like this. Why copper and chromium show exceptional electronic configuration? You know, chromium shows half-filled configuration, and this one, which one? Copper show full-filled configuration, right? 3D10 for copper and 3D5 for chromium. Why they are showing an exceptional configuration like that? Same question they can ask like that also. Okay. Basically, there are two reasons. One is due to symmetry. Okay. Listen. Symmetry always leads to stability. If something is more symmetric, then it is more stable. Okay. Now, for D5 and D10 configuration, electrons are evenly spread out, uniformly spread out, which make it more symmetric, also more stable. Second is about exchange energy. See, this stabilizing effect arises whenever two or more electrons with the same spin are present in the degenerate orbit of a subshell. What happened to these electrons? They exchange their position. When they exchange their position, definitely energy is used up, right? Okay, if energy is used up, energy is decreasing. If energy is decreasing, then what will happen? Stability will increase. That you must know, okay? Energy and stability relation. If energy reduces, stability increases. Now here, more exchanges, more reduction of energy, higher will be the stability. So what is the second point? So more electrons with the same spin. If you check half-filled configuration and full-filled configuration, you can see there will be more number of electrons with the same orientation of spin, and they can change their position. If they change their position, see, more energy is reduced. More reduction in energy will give them what? More stability. Clear, right? Okay. So symmetry leads to stability, less energy leads to stability. Okay. So which are the two reasons due to which half-filled and full-filled configurations are highly stable? First is due to symmetry. Second is due to exchange energy. See, this is very, very important. Okay, this question is very, very, very important.